As it says here, Yohan is going to be talking about non-collaborative user simulation. And Yohan is, as many of you may know, also an assistant professor over in Seoul National University. He's been working on cognitive reasoning, agentic systems, and pluralistic value alignment, all which are very correlated to the workshop's themes. So we'll be hearing a keynote from him to start off the session. And again, please feel free to ask questions out loud anytime. I think Yohan is happy to take questions in the middle of his talk. Okay. And also on Menti. Okay. So without further ado, we'll let Yohan share his screen and he can take the stage. Okay.
Okay. Can you hear me okay? All right. Thank you very much. Hi, everyone. I'm Yohan Jo from Seoul National University. So in this talk, I'm going to be talking about non-collaborative user simulation. So the main theme of this workshop is collaborative AI. But why is collaboration so difficult? Because people have different communication styles, different knowledge levels, and willingness to cooperate. So a key challenge in collaboration is human diversity. This is why many researchers use user simulators to train and evaluate their chatbots. So these user simulators take user persona cards as prompts, and they simulate diverse user behaviors according to this given user persona card while interacting with a chatbot. But my question is, are these user simulators really diverse enough? And my answer is not much, because their backbone LLMs are still trained to be helpful, harmless, and honest. So let's take emotional support as an example. Typical user simulators would say something like this: "Oh, thank you so much for being here and listening. I've been feeling really overwhelmed lately. The anxiety makes it hard to get out of bed some days, and I worry about the future a lot. What helps me a little is talking to people who understand, trying to take small steps, and reminding myself that it's okay to have hard days. I'm working on self-care and staying hopeful. Do you have any other suggestions that might help me cope better?" So very clear and very detailed and very receptive. And these typical user simulators, they easily change their mind. They easily accept the chatbot's advice. But what about real Reddit users? They're more like, I don't know, that doesn't work. This sucks. And they even swear. So if a chatbot is trained and evaluated only on nice and collaborative user simulators, it is highly likely to collapse when interacting and collaborating with diverse users out there. But still, this chatbot's performance is highly likely to be overestimated. So this chatbot is suffering from an echo chamber effect. So let's build non-collaborative user simulators. So in this talk, I'm going to cover 3 case studies: emotional support chatbots, medical diagnosis chatbots, and tool agents. In each case study, I'm going to talk about how to build a non-collaborative user simulator and what limitations chatbots exhibit when interacting with these non-collaborative user simulators. And I will introduce some techniques for mitigating these issues as well. Okay, let's begin with the first case study, emotional support chatbots. In emotional support, people show very diverse behaviors. Some people, they're very open to advice, but a lot of people, they resist other people's advice. And some people, they actively disclose their information, but a lot of people hesitate to reveal their information. So we came up with this taxonomy of 9 psychological and linguistic features that we want to control for a user simulator. So they are resistance level, self-disclosure level, and coping strategy, engagement level, sentiment distribution, utterance style, verbosity, profanity, and dialogue length. So the basic idea is we prompt a user simulator LLM with these 9 user features and the main problem the user is suffering from. However, these typical user simulators, it's very hard to elicit the expected behavior because their backbone LLMs, they're just trained to be very helpful and trained to be very harmless. So usually what happens is that even if we raise the resistance level, or even if we lower the self-disclosure level, these user simulators tend to be very receptive and very self-disclosing. So simple prompting doesn't work. That's why we trained a controllable user simulator. For this, we collected a lot of Reddit threads from the Off My Chest and mental health subreddits. So for each Reddit thread dialogue, we annotated the 9 user features I mentioned earlier, like resistance level, self-disclosure level, and so on, based on the original poster's utterances, as well as the main problem the OP is suffering from. And based on this data, we trained a user simulator, Llama 3 in this case, to take these user features and the problem as input, as a prompt, and speak like the original poster in this dialogue. So this way, we are able to make this user simulator better adhere to the given user features, as well as speak naturally like general online users. And for this user simulator, technically, we used a mixture of expert architecture, which really helped the simulator better adhere to the given user features. I will talk about it more later if you're interested. So using this user simulator, we did emotional support chatbot evaluation. So in this evaluation, there are multiple emotional support chatbots we want to evaluate, and they interact with diverse user simulators, including our user simulator. And for our user simulator, we used 300 user profiles collected from Reddit. And for each dialogue simulated between a emotional support chatbot and a user simulator, we used GPT as a judge to evaluate the emotional support skills of this chatbot. So here are the scores of GPT-5 Mini on 5 different emotional skills. So they are problem identification skill, comforting, and providing suggestions, sharing useful experiences, and being informative. And here the gray bars are the scores of GPT when it interacted with typical collaborative user simulators from prior work. And the blue bars are the scores when GPT interacted with our user simulator. And we can see that the scores dropped substantially when GPT interacted with our simulator. So this chart shows that typical user simulators can overestimate the emotional support skills of different chatbots. And human experts, they identified 2 main failure modes of these chatbots when interacting with non-collaborative user simulator. First, when the user simulator resists advice or stays in negative mood, these chatbots tend to be overly apologetic instead of offering constructive feedback or suggestions. And second, when the user simulator provides short answers, these chatbots tend to keep asking boring, probing questions one after another. So the main takeaway here is use general online conversations to train controllable user simulators to effectively simulate diverse user behaviors and reveal vulnerabilities of chatbots. And let's move on to the second case study, which is medical diagnosis chatbots. The main goal of chatbots here is to be deployed in emergency rooms and ask patients about their symptoms and predict a diagnosis. But a main challenge here is that patients, especially in emergency rooms, they tend to provide or describe their symptoms only vaguely, like my ankle's been feeling off. So the chatbot should ask good clarifying questions, like does it hurt when you put weight on it? And this chatbot should narrow down the root cause as quickly as possible. And this can help triage patients in emergency rooms. So in this problem, patient simulators usually, they take a patient profile as a prompt. So these patient profiles contains the age, the sex, history, and medications and lab results of a patient. And this patient simulator is supposed to provide this information to a diagnosis chatbot little by little, based on the diagnosis chatbot's questions. However, what usually happens is that instead of providing this information little by little, typical patient simulators, they provide this information, they describe the patient's symptoms too clinically and in too much detail, almost like a medical expert. So the chatbot cannot learn to collaborate with real patients to identify the root cause and the diagnosis of the patient, because real patients, they're usually very inarticulate and their responses are often underspecified, especially in such a stressful situation in emergency rooms. So what we did was we took an existing patient simulator called Patient Sim, and we made a very simple tweak. We instructed this patient sim to respond with low specificity, like real patients. And 3 board-certified physicians compared our simulator and the original patient sim, and they preferred our simulator 46.3% of the time compared to patient sim 24% of the time. And they cited realistic vagueness as a key factor of the positive evaluation of our simulator. Now, we use this vague patient simulator to train a diagnosis chatbot to better collaborate with real patients. So this patient simulator takes a patient profile, user profile as an input. And this profile contains the age of the patient, the gender, and the symptoms and true diseases. And we collected these patient profiles from Mimic4ER, which is a large-scale emergency room database. So this patient simulator takes this patient profile and begins the conversation with a vague symptom description, like my ankle's been feeling off lately. And then the diagnosis chatbot first takes the dialogue history and predicts the top 4 plausible diseases based on the dialogue so far. And then, using this predicted diagnosis, we retrieve a relevant subgraph from a clinical knowledge graph. So to retrieve this subgraph, we actually do 3-hop expansion from the predicted diseases. So first, we begin with a predicted disease, and then we do a 1-hop expansion to include the related symptoms and causes and risk factors of this disease. And then we do 1 more expansion to include other diseases that share these symptoms and causes and risk factors. And the last expansion to include other symptoms, causes, and risk factors related to these new diseases. So this is 3-hop expansion. So the key idea of this expansion is that this subgraph helps the chatbot identify which diseases are shared across, which symptoms are shared across multiple diseases and which symptoms are discriminative. So it helps the chatbot ask sharp, clarifying questions. So based on this subgraph, this diagnosis chatbot decides whether to ask a clarifying question about patient's symptoms or to make a final diagnosis. So the conversation goes back and forth. And this simulated dialogue, if it reaches the true gold disease at the very end, we use this as a training data. We use this as training dialogue to train this diagnosis chatbot. So here's the evaluation results of diagnosis chatbots. So recall at 4 measures whether the top 4 predicted final diagnoses include the true gold disease of the patient. And here we can see that our chatbot outperforms much larger commercial and open source models on the left, and also outperforms a similar sized baseline models here. And this is the number of turns per dialogue. So in emergency rooms, you cannot expect to have a long conversation with patients. So shorter conversations are preferred. And again, our chatbot shows the lowest number of turns, average number of turns per dialogue, except for one baseline. And the human experts, physicians, they scored our chatbot positively for its clinical authenticity, as well as the essentiality of the questions this chatbot asks, and also the naturalness of conversational flow. So the main takeaway here is to handle vague and underspecifying users, you may consider using domain knowledge graphs to ask discriminative clarifying questions. Okay, this is the last case study, which is about general tool agents. So most LLM-based agents today, they use external tools. So let's take a travel agent as an example. The user says, I need to book train tickets from Cambridge to Norwich. Then the chatbot, the agent says, sure, when is your departure date? The user goes tomorrow. Then the agent calls an API to search for available trains. And then responds, 2 trains are available, 9 a.m. and 7 p.m. Which one do you prefer? And then the conversation goes back and forth. And at the very end, the agent may call an API to book train tickets and then respond, your reservation code is 12CB, etc. So this is a typical conversation between a user and an LLM-based agent that uses external tools using APIs. Now, in this problem also, many researchers use user simulators either to train or evaluate their agents. So what happens is a user simulator takes something called goal statement as a prompt, and this goal statement specifies all the constraints that this user simulator should inform the agent of, such as the date of the train, the time of the train, the number of people, the departure and destination stations, etc. And this user simulator is supposed to provide this information to the agent in response to the agent's questions. But what usually happens is for typical user simulators, they provide this information fine, but provide only requested information very, very clearly without any distractions, which is very different from real users who are much messier, who get confused a lot, and who get angry a lot. So if a chatbot is trained only on these nice and collaborative user simulators, they're likely to collapse when deployed to the real world. So we defined 4 non-collaborative user behaviors. The first is an available service, in which the user requests a service that is not supported by existing APIs. For example, book me a window seat, where seat preferences are not supported by any APIs. And the second non-collaborative behavior is tangential. The user talks about things they're not directly related to the task at hand. Like, by the way, some of my friends visited Cambridge recently and they really liked it. And the third type is impatience. So here the user gets angry and the user complains when the agent struggles. Like, why is this taking so long? Can she even do something this simple? And the last one is incomplete utterance. This usually happens in a more like a text-based chat setting, where the user accidentally hits enter before finishing a complete sentence, like reserved for. So we injected these 4 types of non-collaborative user behavior into a user simulator using both prompts and some specialized modules. I'm not going to cover the details here. And we evaluated several LLM-based agents using 2 benchmarks here. One is TauBench, and the other is MultiWords. So TauBench is for making, updating, or canceling airline reservations and retail orders. And MultiWords is for booking hotels, restaurants, trains, and taxis. So in each benchmark, an agent interacts with a user simulator, and also it calls APIs, which change the DB state of the environment. So we have this conversation for up to 30 turns, and then the final DB state at the end of the conversation is compared with the gold DB state. And if they match, then we consider this task to be successfully completed. So here's the agent evaluation result on TauBench, and MultiWords shows similar patterns. So here, the gray bars indicate the task success rates of these agents when they interacted with only a collaborative user simulator. And the blue bars are their success rates when each non-collaborative behavior was injected into the user simulator. So we can see that the success rates substantially drop when the user simulator shows non-collaborative user behaviors, especially for Llama 3.1. And we identified several failure modes that agents struggle with. So for an available service, agents tend to repeatedly call helper functions to request API documentation, trying to find a tool that does not exist. So instead of acknowledging that we cannot support this request, it keeps searching for API documentation. And some agents, they just hallucinate API results. And the second non-collaborative behavior, tangential, agents often get distracted by off-task user remarks and fail to complete the core task within limited terms. And for impatience, agents, they tend to apologize excessively, which delays task completion and triggers even more user frustration. And lastly, for incomplete utterance, agents struggle to identify missing or poorly articulated information. And instead of asking follow-up questions or clarifying questions, they often end up hallucinating API input parameters. So in many cases, agent developers would fine-tune a small language model on pretty much clean data. So we also try this using Qwen 2.53b model. This is a small language model. And without any training, this LLM cannot really achieve any tasks. So its success rates remains below 4%. But when we fine-tune this model only on clean data, that is simulated dialogues between this model and a collaborative user simulator that leads to successful test completion, if we fine-tune this model on these clean collaborative dialogues, then its performance on the left on collaborative user simulator skyrockets to 90%. But its success rates on non-collaborative user behaviors still lag far behind. But if we fine-tune this Qwen 2.53b model on a mix of collaborative simulated dialogues and non-collaborative simulated dialogues together, then we can achieve more balanced success rates across different behavior types. So the main takeaway here is simple fine-tuning on even simulated dialogues that include messy user behaviors like unavailable requests, tangential speech, impatience, and incomplete utterances can make your agents much more robust to such users and make your agents collaborate better and effectively with non-collaborative users. So in this talk, I argue that effective human-AI collaboration requires AI systems to be exposed to diverse user characters during training and evaluation. And typical user simulators are based on LLMs that are trained to be helpful, harmless, and honest. So maybe we should inject more realistic user behaviors, which are often non-collaborative. And we revealed several failure modes of chatbots and suggested methods for improving these models by grounding in a knowledge graph and fine-tuning them with non-collaborative simulated dialogues. And of course, there are several limitations remaining here. First, we basically handcrafted these non-collaborative user behaviors. But how can we avoid this? How can we scale this up to include realistic user behaviors in less laborious ways? I think this is something we need to think about. And the second one is how can we ensure the realism of these user simulators? So for this, in the emotional support case study, we collected a lot of Reddit threads, which are authentic emotional support conversations. And we trained a user simulator on these authentic conversations to make these simulators speak more naturally, like general online users. But in many domains, we don't have such real-world data. So in that case, how to ensure the realism of these user simulators is something worth discussing together in this workshop, I guess. So with this, I'm going to finish my talk here, and I'm happy to take any questions. Thank you.
Great, we have plenty of time for questions. So maybe we can take one from the floor first. You have questions? B? Yeah. Yeah.
Yeah, I really like the talk. I have a general question first. So when we think about evaluation of user simulators, it seems the main paradigm today is to compare simulated users with some kind of ground truth or with some kind of reference. And then you can design different dimensions to see like, oh, does my simulated user align with the reference? Do you think that this is a way we should go to evaluate user simulators, or should we think about some other things? Because even if I think about myself, if we have two separate conversations, it's unlikely that my behaviors will be similar. Sometimes it just change from session to session. So yeah, I wonder whether we should be thinking a different dimension in terms of user simulator evaluation.
Okay, thanks for the question. So basically, Dee mentioned that to evaluate the realism or the quality of user simulators, we often use some reference responses or utterances of real users and compare the user simulators utterances with them. And is this a good way to go? Well, I also do that too. So for example, for emotional support user simulator, for example, we have some reference human-human conversations out there. And we basically analyze different characteristics of the user simulators utterances and the human patients or clients, help seekers, their utterances, and we compare them and we say, oh, they have similar, like characteristics. So this simulator is quite valid, something like that. I think this is good way, but it also has limitations because the fact that this user simulator has similar characteristics does not necessarily mean that this simulator is realistic. So we often also do let human experts evaluate the dialogues and then evaluate the realism of this user simulator. I think that's very important. For example, in our diagnosis chatbot study, we actually asked certified physicians to evaluate the dialogues, simulated dialogues, and we asked them to evaluate the realism and different characteristics of the patient simulator, and I asked them whether these patient simulators utterances reflect the real world patients, their utterances as well. So I think we should go both ways, and that way I think they can complement each other.
Do we have more questions from the floor? Okay, one moment.
Just now you mentioned training for the for either simulators or the chatbots. So I mean, I know if training is required or is like simply typing a system prompt be sufficient?
Okay. Thanks for the question. So the question is whether we really need to train a user simulator or a chatbot too, or just user simulator. Yeah, so I think the question is relevant to this part. So this emotional support, like user simulator. So we first tried just prompting this user simulator LLM with several user features and the main problem, but we cannot really control this user simulator. This simple prompting cannot really effectively elicit the expected behaviors in the prompt, especially for resistance level and self-disclosure level. That's why we decided to train a user simulator. And also the conversation style, the utterance styles of default LLMs, they're very different from how people really speak in Reddit or just general online conversations. So that's why we trained this user simulator using Reddit dialogues. And I think this is necessary. Otherwise, especially in domains like emotional support, these nuances in conversation styles, they're very important for the realism of this conversation. But I don't think just default LLMs can simulate real-world users in this domain specifically. So yeah, may depend on the domain. For example, like tool agents, we didn't really train any user simulator because I think in that domain, just backbone LLMs, they're quite good at just simulating, a lot of users out there. I think this is partly because in that domain, the user's role is simply provide some information to the agent in response to the agent's questions. But here in the emotional support domain, it's not just question answering. It's more like describing their psychological states and their information, their experiences, and so on. So in this case, I think training is necessary.
Okay, we have another question from Zishen, but I'm going to take one online first, and I'll come back to you. We still have plenty of time, so don't worry. Let me just refresh here. Okay, so there are a couple different questions. So I wrote some of these myself just to get started. So I'll just ask one of them. So people may react quite differently to chatbots. I think this is a little bit like Dee's question earlier, versus actual human users. So how does your first work address this? I mean, I think Dee was asking more from the point of view of having multiple ground truths that might be correct.
Yes, that's a good question. Could you share my display my screen? So this is exactly because we wanted to give more control to the user simulator. So instead of us deciding how to behave for the user simulator, we just decided to provide a technology to control different user features for this user simulator. So that's why we came up with these 9 psychological and linguistic features. And based on using these 9 features, we can basically simulate a lot of diverse user behaviors. So how to decide the feature values here? It really depends on your target audience. For example, if you develop an emotional support chatbot, and this chatbot is an online chatbot, so it basically talks with anyone who comes to your website, for example, who visit your website, for example, then you may want to reflect this user simulator. You may want to make this user simulator reflect general online users like Reddit. So basically, you can analyze this Reddit data and obtain the distribution of their user features on this Reddit, and then you simulate those users using these different features. And if you are targeting more like in-person psychotherapy, then those clients may have more focused user features, like they may disclose their information quite more, or they're more engaged. They may talk more, like they have a higher verbosity, for example. They never swear. I mean, I hope they never swear in their in-person psychotherapy. So you can control these features to simulate those incoming, in-person psychotherapy clients using these features. So I'm not saying that like certain configuration of these features is the right configuration for any users, but we just wanted to give a control to agent developers. Depending on the target audience of their chatbot, they can control and simulate diverse user behaviors using this technique.
Okay, thanks so much for answering that question. So we'll take one more question from Zishen.
Thanks for the really interesting talk. Yeah, I've actually been working with students on related projects, so it's really helpful to see all the stuff you've been finding about the, how real users actually differ from the standard kinds of user simulators. So I guess one way I've historically thought about simulating human users is more from this kind of RL sequential decision making perspective, right? Where the main thing you sort of model the user in these embodied contexts where you assume they're rational, they have like utility functions and they sort of try to maximize them. And that's one kind of tradition of human user modeling, right? Or you assume you're boundedly rational to various degrees. And I'm kind of curious now, and it's quite different from the world where we're now in, where humans have the ability to express themselves in text instead, where it's not clear how you would model them as like rationally conversing in text. But one thing I guess where you do want to have a bit more of that is in more of these like dual control benchmarks, for example, like How-To Bench, or more embodied AI settings where the user both speaks to the AI but also takes actions in the real world. I'm curious if you've like thought about how to train diverse user simulators or potentially non-collaborative user simulators in that context.
Yes, I think that's a good question. We actually submitted a paper, it's under review, about voice-based user simulator. So this is exactly targeting benchmarks you mentioned, like How-To Bench, or more like audio-based voice assistants, because there's not many user simulators who that interact with agents using audio. So for that user simulator, we injected several non-collaborative behaviors as well. For example, back channeling and barging, and I think 2 more features that real-world users show. So yeah, I think that's a promising direction, and especially barging is very common in real-world interaction with voice assistants. So and it's also technically not straightforward because the thing is we usually use like multimodal language model or omni model for this user simulator, voice-based user simulator, and then usually how this model works is it takes audio from the agent, the complete audio, and then it starts speaking, right? But barging means it should decide whether to when to stop listening and then starts its utterance, right? So we had to change the architecture of the model a little bit. So at every frame, we decide whether to barge in or not. And if we decide to barge in at a certain point of the agent's audio, then the user simulator begins talking. So I think there are several like techniques and tweaks we can make for this, like voice-based user simulators. Thanks.
Okay, so let's thank Yohan again for his talk and QA. Very informative. I think our next speaker is Nancy. So Nancy has some audio she needs to set up, so we'll try to get that working. Just give us a couple minutes to set up. You don't need a connector, you can just share screen with. See whether you can put this on. To share sound, you're doing that already. Okay.